You ever wonder how something like ChatGPT gets so ridiculously good at language? Well, the secret sauce isn't just throwing more data at it or having faster computers. It's this really clever idea called the attention mechanism. So let's get into it. Let's break down this concept that literally taught machines how to pay attention.
I mean, to you and me, that's simple, right? But for a computer, it's a huge problem. You've got the exact same words, but the order changes everything. And for the longest time, this whole issue of context and, word order was a massive roadblock for AI. So the big question was, how in the world do you teach a machine that order matters?
Okay, so the first big hurdle they had to clear was memory. Think about it. To understand a sentence, you have to remember what words came first. A machine needed to learn that too. Sounds obvious to us, but for the engineers building these things, this was a really tough nut to crack, for decades.
So the first few tries at solving this kind of fell flat. First up, you had what's called the bag of words model. And it's literally just a bag. It counts the words, it knows which ones are there, but it has absolutely no idea what order they're in. So to this model, man bites dog is the exact same thing as dog bites man, totally useless for meaning. Then you have your standard neural network. It can process stuff, sure, but every time you give it something new, it's like starting with a blank slate, no memory of what it just saw. Yeah, so both were basically dead ends if you wanted to understand actual language.
All right, so the challenge was pretty clear. They needed to build a system that could read a sentence sequentially, word by word, just like a person does. And it had to carry that meaning along with it from the start to the finish. Bottom line, it needed a real memory.
And that's when we got the first real breakthrough, recurrent neural networks, or RNNs for short. This was like the first serious shot at giving a neural network some kind of lasting memory. And the big idea here was actually pretty elegant. You see that loop in the diagram? That's the secret sauce. What it does is it lets the network take its output from one step and feed it right back in as an input for the next step. This creates something called a hidden state, which is really just a fancy term for a memory. It helps the network remember what it's already seen.
But, and there's always a but, right? This brilliant idea had a major flaw. Because of that loop, to keep the memory and the word order straight, an RNN has to process everything one step at a time. You can't skip ahead, and this created a huge bottleneck. It was just painfully slow, especially if you were feeding it, say, a whole paragraph or an article.
And it wasn't just that. The problems really started to stack up. For one, the memory was pretty short-lived. If you had a really long sentence, the info from the beginning would just kind of fade away by the time it got to the end. That's what they call the vanishing gradient problem. So not only was it slow, but because that memory was so weak, it had a really hard time connecting a word at the start of a paragraph to a related word way at the end. Okay, so then came an upgrade called an LSTM. That stands for Long Short-Term Memory Network. And it was better, for sure. It could hold onto that memory for longer. But it didn't actually fix the root problem. It was still processing everything one word at a time. It's like trying to read a whole book by looking through a tiny keyhole. It was never going to be fast enough.
Okay, so this is where the story gets really interesting. Researchers realized they needed a totally new approach, a real game changer. And that's exactly what they got. It was called attention.
And this part is really key. Instead of just trying to make the memory chain longer and better, they asked a completely different question. What if the model could just look at the whole sentence at once and then figure out for itself which words are the most important to understand any other word in that sentence? And boom, that's precisely what an attention mechanism does. It lets the model give every single word an importance score. It weighs how relevant each word is for whatever it's trying to do. Basically, it learns to focus on what actually matters.
And just to show you why this was such a big deal, let's stack it up against the old ways. You have your standard layer, right? It just listens to everything equally. It's like being in a noisy room and trying to hear one person. Then you have a convolution layer, the kind they use for images a lot. It only pays attention to its immediate neighbors. But an attention layer? Wow. It can scan the entire sentence, from beginning to end, and actively decide which words, near or far, are the most important to focus on right now. It's basically a superpower for AI.
So then, this idea got even more powerful. It evolved into what we call self-attention. And this is the thing. This is the mechanism that really unlocked what modern AI can do. Let's use a super simple sentence to see how it works. When the model looks at the word chased, self-attention lets it make a strong connection back to cat. That's who's doing the chasing. And mouse, that's what's being chased. It figures out all these relationships inside the sentence all by itself.
And the really crucial thing to get here is that the model isn't just looking at, a prompt you gave it. It's looking inward. It's analyzing the sentence itself. Every word gets to look at every other word in that same sentence. And by doing that, it builds this incredibly rich internal map of what everything means in context.
So how does this magic actually happen? Well, it's kind of like a four-step dance. First, for every single word, the model creates three things: a query, a key, and a value. You can think of the query like a question the word is asking. Hey, what information do I need to understand myself better? The key on every other word is like a label that says, here's the kind of information I have to offer. So the model takes the query from one word and matches it against the keys of all the other words to see which ones are the most relevant. It gets these relevance scores, which then get turned into weights. And finally, it uses those weights to mix together all the other words' values. What you end up with is a new version of that original word, but now it's packed with all this amazing context from the rest of the sentence.
And the benefits of doing this were just huge. Suddenly, the model could see the entire context of a sentence all at once. It could change its focus on the fly depending on the task. And, this is the big one, it completely smashed that sequential bottleneck we talked about. Since every word is looking at every other word at the same time, you can do all of this in parallel. You can run it on modern GPUs, and it's lightning fast. This made the whole process incredibly fast and, more importantly, scalable.
Now, this breakthrough wasn't just some neat idea in a research paper. Self-attention became the absolute core, the engine that drives the large language models we're all using today.
So let's just quickly trace that journey again. We started with just counting words in a bag of words. No order, no context. Then we moved on to the slow, one word at a time memory of RNNs and LSTMs. And now we're here with self-attention, where we get super fast parallel processing and this dynamic all-at-once focus.
When you get down to it, an AI's ability to do things like write a poem, or summarize a long article, or answer some really tricky question, it all comes back to this one fundamental skill, the ability to pay attention. It really was the missing piece of the puzzle. It's what finally allowed AI to get a handle on that complex web of context and meaning that makes up human language.
And all this leaves us with one last kind of mind-bending question. For all of history, we humans have been the only things on Earth that can pay attention in this really focused, complex way. But now, we've built machines that can do it too. And they can do it at a scale that's almost impossible for us to imagine. So, what are they going to notice that we've missed? What connections are they going to find that have been hiding in plain sight this whole time?